professor at LG Institute of Engineering and Technology. Today we will discuss few more examples of Fourier series. So let's begin with the first example. Find the Fourier series of function fx is equal to x plus mod x in the interval minus pi to pi. Okay, so firstly we'll find a0. So the formula to find a0 is 1 upon pi integration minus pi to pi fx dx. Substitute the value of function fx. So we have 1 upon pi integration minus pi to pi x plus mod x dx. Now split the integration, so you will get 1 upon pi integration minus pi to pi x dx plus minus pi to pi mod x dx. Okay, now we know that when we have a symmetric interval and if the function is even, then this integration of minus L to L fx dx is equal to 2 times 0 to L fx dx. And if the function is odd function in a symmetric interval minus L to L, then the integration will be equal to 0. So we will apply this formula in integration. Okay, so firstly we had x. So x is an odd function, so its answer is 0, and later we had a mod x, that is even function. So here we have written 2 times 0 to pi mod x dx. Now in the interval minus pi to pi, and suppose 0 is here, so in this interval x is greater than 0, right? So here in place of mod x we will write only x. So here we have 1 upon pi 2 times integration 0 to pi x dx. Okay, integrated, so you will get x square by 2. Substitute the limit, so you will get the final answer of a0 as pi. Now let's find the value of an. So the formula for an is 1 upon pi integration minus pi to pi fx cos n x dx. Okay, so again the function fx is what? X plus mod x. Okay, now firstly split them, right? So here we have x cos n x and mod x cos n x in the interval minus pi to pi. Okay, now again we know the x cos nx is an odd function, okay, and mod x cos nx is an even function. So the integration of this function will be equal to 0, and the integration of this term will be equal to 2 times 0 to pi mod x cos nx dx. Again, in the interval 0 to pi, mod x is greater than 0, x is greater than 0, so mod x is equal to x. So we have an as 2 upon pi integration 0 to pi x cos nx dx. Okay, now to integrate it, again we have to apply this uv rule formula, right? So integration u dot v is what? uv1 minus u dash v2 plus u double dash v3 and so on. Okay, so here your u is what? X, and v is what? Cos nx. So u as it is, v1 means integration of cos nx. So here you will get sin nx upon n minus derivative of x, that is 1, and integration of sin nx, that is minus cos nx upon n square. Substitute the limit. So firstly we'll apply the upper limit. Okay, so on applying the upper limit we have 2 upon pi, and here firstly sin n pi, we know this value of sin n pi 0, so this term is gone, this minus minus plus, and here we have cos n pi upon n square minus, now lower limit. Okay, so when you will substitute 0, so this term is 0, again minus minus plus, so here you have cos 0 upon n square. Now we know the value of cos n pi, that is minus 1 raised to n, and cos 0 is 1, so here just write down 1. Take n square out, so the final answer of an is 2 upon pi n square into minus 1 raised to n minus 1. Okay, now we will find Vn. Okay, so this is the formula for Vn. So Vn is equal to 1 upon pi integration minus pi to pi fx sin nx dx. Okay, now substitute the value of function fx. So here we have Vn is equal to 1 upon pi minus pi to pi. Fx is what? X plus mod x, and sin x as it is, again split them. So you will have 1 upon pi x sin nx and mod x sin nx dx, and the limit of integration is minus pi to pi. Now we know this x sin nx is even function and mod x sin nx is odd function. So integration of this term will be 0, and integration of this term will be 2 times 0 to pi x sin nx dx. Okay, now we will integrate this. So Vn will be equals to 2 upon pi integration 0 to pi x sin nx. Again, to integrate this, we have to apply this UV rule. Okay, so the formula is what? UV1 minus U dash V2 plus U double dash V3 and so on. Okay, so this x is your U and this sin nx is V. Okay, so just apply this formula. Firstly, x is kept as it is. Integration of sin nx is minus cos nx upon n minus U dash means derivative of x, that is 1, and integration of cos nx is what? Sin nx minus, and 1n is already present, so here we have n square. Now apply the limit. Okay, so firstly here you will get minus pi cos n pi upon n. When you will substitute pi here, so here it will become sin n pi, and the value of sin n pi 0. When you will substitute 0, so here x is present, so this term is 0, and sin 0, we know the value of sin 0 as 0. So what remains is minus pi cos n pi upon n. Okay, now we know the value of cos n pi, that is minus 1 raised to n. So the final answer of Pn is minus 2 upon n into minus 1 raised to n. Now we will substitute the value of a0, an and bn in this formula. So the formula is what? a0 by 2 plus summation n from 1 to infinite an cos nx plus bn sin nx. Okay, so a0 is pi, so here we have pi by 2 plus summation the value of an, and here the answer of bn. Just substitute it, so you will get this final answer of fx. Okay, now let's see one more example. That is, find the Fourier series of function fx is equal to x in the interval 0 to 2 and 4 minus x in the interval 2 to 4. Okay, so in all total we at the interval 4, so period p is equal to 12, right? You can see here the 0 to 4. So here we have the form of interval 0 to 12, right? So period t is equals to 4, and so L will be equals to 2. Okay, now firstly, we will find a0. Now you can see here we have numbers in the terms of L, right? So we will apply this formula. So a0 is what? 1 upon L integration 0 to 2L fx dx. Now the question is given in two parts. So we will split the integration in two parts. That is from integration 0 to 2 and from integration 2 to 4. Now you know that in this interval 0 to 2 the value of function is x. So in the interval 0 to 2 in place of fx we will write x. And in the interval 2 to 4, in place of fx, we will write 4 minus x. Okay, just integrate it. So here you will get answer x square by 2 and the limit is 0 to 2. And here you will get 4x minus x square by 2. And the limit is here is what? 2 to 4. Okay, just apply the limit and simplify. So you will get the answer of a0 equals to 2. Now let's find an. Okay, so the formula to find an is what? 1 upon L integration 0 to 2L fx cos n pi x upon L dx, right? Firstly, the question is given in the two interval, right? So firstly we will write that interval. So in the interval 0 to 2 and the interval 2 to 4. In this interval the value of function is x, and in the interval 2 to 4 the value of function is 4 minus x. So just substitute the value of function. Okay. Now to solve this integration, both the integration, we have to apply again the same formula, right? That is integration u into v dx is equals to uv1 minus u dash v2 plus u double dash v3 and so on. Okay, so here x is u and this cos is v. Again, this 4 minus x take as a u and this is v. Right, and apply this formula. So first here you can see u as it is, so x as it is, and integration of cos. So here we have sin n pi x upon 2 and divide by n pi by 2 minus derivative of x. So here we have 1 and the integration of this sin term, that is minus cos n pi x upon 2 upon n square pi square by 4, and the limit is 0 to 2. Similarly, we have to apply this uv rule for this integration 2 to 4 minus x cos n pi x upon 2. Okay, so you will get this term. Now we have to apply the limit. So in this step, just I have substitute the value of limit. Now we will simplify this. Okay, so on simplification we are getting this term. Whenever we have sin n pi, so that term will become 0. So whenever you have sin n pi and 0, that term will get cancelled and what remains is presented here. Okay, now just substitute the value. So we know the value of cos n pi is minus 1 raised to n and cos 0 is 1. So on substituting you will get this answer. Now further simplify to get the final answer of an as 4 upon n square pi square into minus 1 raised to n minus 1. Okay, now let's find the value of Bn. Okay, so the formula to find Bn is 1 upon L 0 to 2L fx sine n pi x upon L dx. Okay, again split in the two parts, integration 0 to 2 and 2 to 4. Okay, so in the interval 0 to 2 the value of function fx is x, and in the interval 2 to 4 the value of function is 4 minus x. Okay, again we have to apply the same formula of UV rule, right? So the formula is what? Integration u into v dx is equals to uv1 minus u dash v2 and so on. Okay, so just apply this formula in both the integration and apply the limit. Okay, so on applying the limit you will get this term. Now again everywhere when we have sine n pi, that term will get 0. Okay, so all the sine terms will get 0. What remains is this. Okay, and again we have to substitute the value of cos n pi. So the value of cos n pi is minus 1 raised to n. So just substitute the value. So you will get the final answer of Bn is equals to 0. Okay, now the formula for fx, that is a0 by 2 summation n from 1 to infinite an cos n pi x upon l plus bn sin n pi x upon l. Okay, so substitute the value of a0, an and bn in this to get the final answer. A0 we know it is 2, so just substitute 2. This is the answer of an, and bn we know it is 0, so this term is gone. Just simplify it, so here you have the final answer of a function fx. Okay, now let's see one more example. The question is, find the Fourier series of a function fx is equal to x minus mod x in the interval minus pi to pi. Also the question can be asked in the form of fx is equal to pi plus x and pi minus x in this interval. That is, in the interval minus pi to 0 the value of function is pi plus x, and in the interval 0 to pi the value of function is pi minus x. Okay, so question can be asked in any form. Now here you can see the interval is minus pi to pi. So we will check whether this function is even function or an odd function, right? So for that, in place of x, just substitute minus x. So here we have x. So in place of x, write down minus x. So here you have pi minus x. Again, here we have x. So in place of x, write down minus x. So this term, okay? Again, here we have minus x. So it will become plus x, and here x. So it will become minus x. Other things are kept as it is. Okay, now we want this in that form of x. So we have to multiply it by negative sign, right? So on multiplying by negative sign, or you can say if you are to take x minus sign common, so you can say in that way also. So on applying the minus sign, this less than sign will change. Okay, so on simplifying here, you will get 0 less than x less than pi, and here you will get minus pi less than x less than 0. Okay, now you can see this in the interval 0 to pi, the value of function is pi minus x. So here also in the interval 0 to pi, its value is pi minus x. Then in the interval minus pi to 0, its value is pi plus x. Okay, so they both are same. So we can say that f of minus x is equal to fx. Therefore the function fx is even function. Okay, so whenever we have even function, bn will be equal to 0. So what we need to find is a0 and an. So firstly we'll find a0. The formula is 2 upon pi integration 0 to pi fx dx. Okay, substitute the value of function. Now from the question you have to take the value of function fx in the interval 0 to pi. So you can see that in the interval 0 to pi the value of function is pi minus x. Okay, now just integrate it. So on integration you will get pi x minus x square by 2, and the limit is 0 to pi. Apply the limit and simplify, so you will get the value of a0 as pi. Now we will find an. So an is what? 2 upon pi integration 0 to pi fx cos n x dx. Okay, just substitute the value of function fx in the interval 0 to pi. From the question you will get the value of function fx in the interval 0 to pi, that is pi minus x. Now to solve this integration, again we have to apply this formula, that is integration u into v dx is equal to uv1 minus u dash v2 plus so on. Okay, so we will take this pi minus x u and cos n x as v and apply this formula. So you will get here 2 upon pi, this u as it is, v1 means integration of cos n x, that is sin n x upon n, minus u dash, so derivative of this term, it is minus 1, and integration of sin n x, we have minus cos n x upon n square, and the limit is 0 to pi. Now, substitute the limit. Okay, so here sin n pi, that is 0, so this term is gone. Here minus minus plus and this minus. So here we have minus cos n pi upon n square minus, now lower limit. Okay, so when you will substitute 0 here, so sin 0 is 0. Again minus minus plus and this minus. So here we have minus cos 0 upon n square. Okay, now we know the value. Okay, so value of cos n pi is what? Minus 1 raised to n, and cos 0 is 1. So here minus minus plus. So 1 is taken here, and here we have minus 1 raised to n. Okay, so this is the final answer for an. Now we will substitute the value of a0 and an in the formula. So formula fx is what? a0 by 2 plus summation n from 1 to infinite an cos nx. Substitute the value of a0 and an. Okay, so on substituting you will get the final answer of a Fourier series of a function fx. Okay, so I hope you have understood. Thank you for watching.